Right now, let's go back and look at different kinds of experiments, but using cards again, to just compare the basic difference of with and without replacement. This is actually a common kind of problem. Again, it'll come in different contexts, and you'll just have to kind of recognize that it's similar to this kind of problem. In this case, we're using a deck of cards. Suppose cards are randomly selected from a deck of cards one at a time without replacement. So they're like being dealt out one at a time, and you get to keep the cards as you get them in order. And we keep dealing until a 7 has been dealt or selected. And then our observation is the number of cards being selected. So this is important when we talk later about random variables. A given experiment could lead you to choosing to observe different things. So like if I flip a coin 3 times, I could observe a sequence of heads and tails, or I could choose to observe how many heads out of those 3 flips. Those two things come from the same experiment of flipping 3 coins, but the observations are different and they lead to a different random outcome. So in this case, we're observing the number of cards that could be basically dealt out by this rule. So the numbers that we could see range from 1 to 49. So you could get a 7, that would be 1 card, you would stop. You could get a non-7 and then a 7, that would be 2 cards. You could get a non-7, non-7, and then a 7, that'd be 3 cards, and so on. But after we deal 48 cards, if we dealt 48 cards, that 48th card could be a 7, which we stop, or if it's not a 7, the next card is a 7, so 49 is the most cards we could deal. So the probability of 1, observing 1 card dealt, is just 4 out of 52 because there's 4 7s that would tell us to stop out of the 52 cards. The probability of 2 cards means we are dealt a non-7, which is 48 possibilities out of 52, and then we're dealt a 7, but there's 4 7s left, and there's only 51 cards left. That's the without replacement. And then for 3, 48 out of 52 is a non-7, followed by a non-7, and followed by a 7. Another way to think of these second numbers and third numbers is there are 47 out of 51 is the probability of getting a non-7 after or given that the first card was a non-7. So the question is, what's the probability that the third card is not a 7? And this is a typical example where you're better off trying to translate the words that are given to you into a more meaningful set of words that have the same meaning but kind of hint at what you're actually doing. According to these rules of this game, third card is not a 7 means that the number of cards selected or dealt is not 3. Those are the same events. But this description, the number of cards selected or dealt, is not 3, is kind of somehow easier to realize what it means. So it's the complement of the third card being a 7, which we've already computed. So the probability of this third card is not a 7 is really just 1 minus the probability of 3 cards being dealt. We've already figured that out, and we just do the subtraction and get about 0.93. Now, if we redo this whole problem with replacement, it means we are dealt a card. We observe what it is. If it's a 7, we stop and observe the number of cards, which would be 1. If it's not a 7, we put the card back in the deck. It gets shuffled or randomized, and then another card is dealt. So the only thing that changes is our sample space, when 1 could be infinite. Any natural number could theoretically occur. And to compute the probabilities of each of these values, again, 4 out of 52, if we get a 7 off the bat. But if we get a non-7 followed by a 7, it's 48 out of 52. But then that card got put back, and then we chose a 7 out of a full deck. And then 3, again, a non-7 followed by a non-7 out of a full deck, followed by a 7 out of a full deck. And we do the same thing as before with the complementation. It's just that our probability of 3 is different because the rule is different. We're using without replacement here. We're using with replacement here. So we get 1 minus probability of 3, which is a slightly different value. And our probability is a slightly different value, 0.94 instead of 0.93. Another way you could think about this is by partitioning. Probability of a third card is not a 7 means that either the first card, the first term here is the first card is a 7, or, mutually exclusive or, we get a non-7 followed by a 7, or we get a non-7, and then any card afterwards. That's not a 7. Those are 3 mutually exclusive pieces of the event. Third card is not a 7. So we just add those up, and it's the same number we had above.